Welcome to Episode 5 of the 5 Domains series. Domain 5, Operationalize AI Solution. 17% of the exam. If the first 4 domains built the model, Domain 5 makes it real. A model that performs brilliantly in development but cannot be deployed, monitored, or maintained reliably has delivered zero value. This domain covers deployment, monitoring, retraining, cost management, incident response, rollback, and lifecycle planning. In this episode, 2 monitoring layers, 5 risks, 2 case studies, 4 PM roles, and your checklist. Let us begin.
Domain 5 defines 6 requirements that every production AI system must satisfy simultaneously. Stability. The system must respond reliably within the required time window. APIs must meet their service level agreements. Failures must be isolated and recovered automatically where possible. Safety. For systems with physical effects, robots, autonomous vehicles, automated equipment, safety is an absolute constraint that supersedes performance. Kill switches, human oversight, and hard-coded safety limits are not optional features. They are Domain 1 and Domain 5 obligations that cannot be traded off. Cost efficiency. Cloud infrastructure, personnel, and third-party APIs represent ongoing operational costs that can erode project ROI if not managed. The business case from Phase 1 assumed a cost model that must be monitored and validated in production. Scalability. The system must handle demand spikes, marketing campaigns, seasonal peaks, without degradation. Auto-scaling eliminates idle resources during low demand periods and adds capacity automatically during peaks. Maintainability. Model updates must be deployable safely, testably, and reversibly. A deployment process with no rollback is an unacceptable operational risk. Compliance and governance. Production logs, model versions, and data lineage must be retained for regulatory audit. Access controls must be enforced. Data handled in production must comply with the same privacy requirements established in Phase 1. These 6 requirements are the operational contract. The PM's job is to ensure the contract is designed before deployment, not discovered after a production incident. Now let us see how Domain 5 maps across the lifecycle. Domain 5 thinking begins in Phase 1, not Phase 6. In Phase 1, Domain 5 identifies 3 operational planning requirements. First, the deployment environment, cloud, on-premise, or edge. This determines infrastructure costs, vendor dependencies, and data sovereignty constraints. Second, the integration points. Which existing systems must the model connect to, receive input from, and return results to? Third, the non-functional requirements. Response time in milliseconds, transactions per second, and availability as a percentage. These constraints directly influence algorithm and architecture choices in Phase 4. In Phase 2, Domain 5 evaluates the real-time data supply chain. Will the data required by the model be available at prediction time in production? At what frequency and latency? Is the data source reliable enough to build a production dependency on? In Phase 3, Domain 5 requires that data preparation steps be packaged as automatable pipelines, not one-time notebook operations. The pre-processing parameters, normalization statistics, encoding schemas, must be saved and versioned so they can be applied consistently to new data in production. In Phase 4, Domain 5 provides the operational constraints that inform algorithm selection. Inference time limit, for example, 50 milliseconds. Memory budget, model file size limit, deployment target, CPU server, GPU cluster, or edge device. A model that cannot meet these constraints cannot be deployed, regardless of its accuracy. In Phase 5, Domain 5 contributes stress testing, integration testing, and scalability testing to the evaluation plan. These results become part of the go or no-go decision, alongside technical accuracy and fairness metrics. In Phase 6, Domain 5 leads. Deployment, monitoring, CI/CD pipeline management, cost tracking, incident response, rollback execution, and model retirement planning are all Phase 6 Domain 5 activities. Every production AI system requires 2 distinct monitoring layers. Understanding the difference is critical for the PM because they require different tools, different alert thresholds, and different response procedures. Layer 1 is infrastructure monitoring. This tracks the technical health of the system. API response latency at the 95th and 99th percentile, request error rate, CPU and GPU utilization, and memory usage. Tools, Prometheus for metric collection, Grafana for visualization and dashboards. Typical alert thresholds. Latency above 500 milliseconds, error rate above 1%, CPU utilization above 80% for more than 10 minutes. These alerts trigger the operations team to investigate infrastructure issues, not the data science team. Layer 2 is model performance monitoring. This tracks the quality of the model's predictions and the integrity of its input data. Data drift is the distribution of incoming features shifting compared to what the model was trained on. Concept drift Is the statistical relationship between features and the target variable changing over time? Business KPI tracking. Is the real-world outcome the model was designed to influence? Inventory cost, fraud loss, support call volume, moving in the expected direction? Tools. Evidently AI, Y Labs, or Arise for drift detection. Typical thresholds. MAPI above 20% for demand forecasting. Approval rate gap exceeding Phase 1 fairness thresholds. Retrieval accuracy below 70% for conversational AI. These alerts trigger the data science team to analyze root cause and decide whether retraining is needed. The PM must ensure both layers are operational before go live, not added later as an afterthought. And the PM must ensure alert routing is configured correctly. Infrastructure alerts route to operations. Model alerts route to data science. There is also a third element, business KPI reporting. Monthly reports on the model's actual business impact, cost saved, fraud prevented, resolution rate achieved, must go to leadership. This closes the ROI loop that Domain 2 opened in Phase 1. Domain 5 has 5 documented failure patterns that account for the majority of production AI failures. Risk 1. Downtime, API stops responding. Causes: hardware failure, bugs, memory leaks, overload, cloud outage. Defense: multiple replicas, load balancing across availability zones. Autoscaling: documented DR plan with tested restore procedures. Infrastructure monitoring with immediate alerting. Circuit breakers in client systems for graceful degradation. Risk 2. Undetected drift. Predictions deteriorate silently. No error, no alert, just worsening business outcomes. Causes: behavior change, market shifts, seasonal breaks. Defense: drift monitoring with thresholds before go live. Monitor indirect business signals. Plan both scheduled and event-driven retraining. Risk 3. Security failures. 3 AI-specific vectors. Data poisoning. Malicious training data injected into pipelines. Adversarial inputs. Crafted inputs fool the model. Model theft. API queries reconstruct the model. Defense: authentication, rate limiting, input validation, encryption, anomaly monitoring, periodic adversarial testing. Risk 4. Cost overrun. Business case budget exceeded. Causes: underestimated traffic, unoptimized infra, third-party API costs. Defense: cloud cost alerts before go live. Monthly review. Autoscaling. Spot instances for retraining. Model quantization to reduce inference cost. Storage cleanup. Risk 5. No rollback capability. New version fails. No tested procedure exists. Downtime extends. Defense: rollback automated and tested before first deployment. Blue-green. 2 environments. Instant switch. Canary. Route small traffic percentage to new version. Promote or revert based on thresholds. A furniture manufacturer with a deployed XGBoost demand forecasting model. Weekly retraining cycle. Used by the procurement team to plan raw material orders. Deployment: Docker container, REST API, built with Fast API, running on Kubernetes with 3 replicas and a load balancer. Blue-green deployment strategy. 2 environments maintained at all times. When the weekly retrained model passes validation, traffic switches from the current environment to the new one. If issues are detected within 24 hours, traffic switches back in minutes. Infrastructure monitoring. Prometheus collects latency, error rate, and resource utilization. Grafana dashboard, visible to the operations team. Alerts. Slack notification when P95 latency exceeds 500 milliseconds, or error rate exceeds 1%. Model performance monitoring. Evidently AI runs weekly, comparing the input feature distributions of the most recent week against the training distribution. If drift score exceeds threshold, an alert routes to the data scientist team. Additionally, the pipeline automatically computes map against actual demand outcomes weekly. If MAPI exceeds 20%, retraining is triggered outside the scheduled cycle. Retraining pipeline. Fully automated with GitLab CI. Weekly trigger. Pull latest 36 months of data. Run pre-processing pipeline. Train XGBoost with saved hyperparameters. Evaluate on a holdout period. Compare to current production MAPI. If new model map is at least 1% better, push to staging for a 48-hour shadow run, then promote to production via blue-green deployment. Monthly business report. Average MAP, number of drift alerts, cloud cost, and uptime percentage, sent to leadership. This report validates the ROI claim from the Phase 1 business case. PM role in this case, designed the RACI matrix for who receives which alert, approved the retraining automation before go live, set the monthly cost reporting requirement. A logistics company operating a fleet of autonomous forklifts in a cold storage warehouse. Multiple AI subsystems, object detection, localization, path planning, motor control. Human workers present in the same physical space. Deployment. AI models run on industrial computers mounted on each vehicle, connected to a central operations hub via wireless network. Software updates are deployed over the air, with extreme caution. A single vehicle cannot have unplanned downtime mid-task. it creates a physical bottleneck. Safety monitoring, the highest priority. 24/7 tracking per vehicle. Collision count. Emergency brake activations, deviation from authorized path, distance to humans and other vehicles, sensor status, LiDAR, cameras, collision sensors, battery level, and motor temperature. Any safety event immediately triggers a Priority 1 alert to the Remote Operations Center. Remote Operations Center, 2 operators per shift, monitor all vehicles on a live warehouse map. Operators can issue a software kill switch to stop one vehicle or the entire fleet, take manual remote control of a stuck vehicle, reroute traffic around a blocked corridor. Physical kill switch. Every vehicle has a red emergency stop button, accessible to any warehouse worker. Drilled monthly. OTA update procedure. Canary deployment with physical barriers. Phase 1. Update one vehicle in an isolated test zone. Monitor for 24 hours with an observer present. Phase 2. Update 10% of the fleet in one zone. Monitor for 48 hours. Phase 3. If all safety metrics remain within bounds, update the remaining fleet in groups. Total update cycle for a major release, 2 to 3 weeks. Rollback capability is immediate, at any stage. PM role in this case, defined the P1 through P4 incident severity classifications, required the monthly kill switch drill, approved the OTA update procedure, confirmed insurance and liability coverage for the testing phases. Key contrast with case study 1, automation level, human oversight intensity, and update caution are completely different. Pattern determines operational profile. Operational requirements differ dramatically by pattern. The PM must know what each pattern demands. Hyperpersonalization requires real-time embedding updates and a cold start strategy for new users. The primary monitoring metric is business performance, CTR, conversion rate, not technical accuracy. Caching infrastructure is critical for latency. Conversational AI requires knowledge-based currency monitoring. The primary operational failure mode is knowledge staleness. The model gives outdated answers because the underlying documents were not updated. Human evaluation sampling is required in production, not just at deployment. Recognition requires environmental drift monitoring. Camera optics, lighting conditions, and product variations in the real world differ from the controlled training environment. A sample of production images must be labeled and evaluated regularly. Anomaly detection requires alert fatigue management. If the false positive rate rises due to drift in normal behavior, operators stop trusting the alerts. Threshold tuning and feedback loops from alert investigation results are required operational activities. Predictive analytics requires automated performance evaluation against actuals. The model's forecast accuracy can only be measured after the forecasted period passes. This pipeline must be built and operational before go-live. Goal-driven and autonomous systems require safety-first operational architecture, kill switches, physical barriers during updates, human-in-the-loop monitoring, and multi-week Canary rollouts. 4 PM roles in Domain 5. The ML Operations and IT Coordinator owns the RACI matrix and a handover meeting. The Rollback and Incident Response Owner builds the procedures, tests them before go-live, organizes quarterly drills. The Cost Manager estimates operational costs against the business case, sets cloud budget alerts, reviews costs monthly. And the Long-Term Maintenance Planner defines update frequency policy, schedules maintenance windows, plans for model retirement, and builds the ongoing operational budget. Use this checklist before go-live to verify that the system is operationally ready. On deployment readiness, is the model containerized with a tested Docker file? Is the API endpoint stress tested against production traffic projections? Is the deployment strategy blue, green, or canary defined and tested? Is the rollback procedure documented and tested? Has the RACI matrix been distributed? On monitoring, are both monitoring layers operational before go-live infrastructure metrics and model performance metrics? Are alert thresholds defined based on Phase 1 requirements? Is alert routing configured infrastructure alerts to operations, model alerts to data science? Is there a business KPI dashboard for leadership? On incident response, is the incident severity classification, P1 through P4, defined? Is the on-call rotation established? Is the runbook written for each severity level? Has at least one incident drill been conducted? On security, is API authentication active? Is rate limiting configured? Is data encrypted in transit and at rest? Are model versions retained for audit? On cost, is the operational cost estimate documented? Are cloud cost alerts active? Is a monthly cost review meeting scheduled? On user and operations team readiness, have end users been trained on model outputs and limitations? Has the operations team been trained on monitoring tools and incident procedures? Is technical documentation complete? The operational readiness checklist is the PM's final gate before going live. No production deployment without this checklist completed. Let us close.
That is Domain 5, Operationalize AI Solution. Quick recap, 17% of the exam, leads Phase 6. Preparation begins Phase 1, 2 layers, infrastructure monitoring and model performance monitoring, both live before go live. 5 risks, downtime, drift, security, cost, no rollback, test rollback before first deployment, blue-green, instant switch, Canary, incremental, auto rollback, autonomous systems, kill switch, plus 24/7 monitoring, plus multi-week Canary, non-negotiable. 4 PM roles, coordinator, incident owner, cost manager, maintenance planner. Next, series finale. All 5 domains connected. Please share with a colleague. Subscribe. This is Peter Pham. See you in the next lesson.